On this computer. Hello, everyone. Good afternoon. Happy Thursday. We've almost made it to the end of our second week of quarter three, which feels very weird because the second week just started yesterday. So today we are just going to be continuing on, with our learning. We worked on 4.2 day one yesterday, which was taking a look at inverses and proving things were inverses. And we're going to be finishing that up today. And after today, you will know all the material that you need to know for our test on Tuesday. Again, just a reminder, the test did get moved back to Tuesday due to power outage shenanigans. Before we take a look, actually, no, I'm just going to share my screen with you first so we can see, kind of look at our calendar. Again, I have all my things on my sticky. So if we take a look here, there we go. If we take a look here, you'll see I have Unit 1 review, Part 1 and 2. We do have two parts of the review that we'll work on tomorrow and Tuesday, Monday, and then Tuesday will be our test. Tomorrow, we're going to talk about a few things. So tomorrow, we're going to spend time talking about the review, what that looks like. We're going to talk about test procedures, what that means. By tomorrow, I'll know how many questions are on the test so I can answer that question. And tomorrow, we will also be able to talk about dual credit stuff. I know a few of you have been asking me about dual credit, how to sign up, things like that. There are 3 steps in signing up for dual credit. We're not able to do steps 2 and 3 yet, but we can start on step 1. So we'll be talking about that tomorrow. But before we get to all that today, like I said, we're finishing up 4.2. So if we head to our Canvas class, and we go to the modules, let this person in. And we go to today's date, which I forgot to change, was originally yesterday, but it should be the 18th. So 4.2 day 2. You should have watched the 4.2 day 2 video last night. It was more continuation about inverses and proving things are inverses through composition. Today's classwork, we're going to be working on the 4.2 Go Formative. I think it has 7 questions. We're going to go over, I think, 4 of them. So this is what we're working on today. Here's an answer key if you want to take a look at that. And then for tonight's homework, I've just kind of posted the review for you. I don't make videos for reviews normally because it's like I've already kind of taught you everything for this unit. This is just kind of extra practice for you. So both review part 1 and 2 are in here. Here are the answer keys. You don't need to finish both reviews tonight, especially because we're working on it over the next 2 days. What I would like for you from homework is to at least glance at the reviews. Just take like a quick skim through, even if you don't do any of the problems. Maybe do a few. But even if you don't do any of the problems, take a skim through and say, hey, I'm going to have trouble with this type of problem. Or like, this looks complicated. I hate it. I should ask Ms. Twain about this. Just that you can come in tomorrow for the review day with questions already. With kind of what you want to go over, like, hey, number 7 in part 2 looks like too much for me. Can we go over that? Or like, wow, I don't remember how to do this. So for homework tonight, I have all the reviews here. You don't have to finish all of them, but at least take a glance at them. At least. You can still do a few problems. So that's kind of the plan for today. I've started to kind of put just some extra notes down here, supplemental things that I feel like we might need, big ideas to get across. And I feel like the big idea to get across today is that when we're determining if 2 functions are inverses of each other, we can prove that by saying f of g of x and g of f of x are both equal to x. Because if 2 things are inverses of each other, kind of like multiplying and dividing, adding and subtracting, they're kind of undoing all of the operations. So if we're undoing all the operations correctly, we should just be left with x. So it's kind of the big idea for the day that we'll be going over. But like I said, we're finishing it up. It's the last of the new material, and then we're reviewing for the next few days. So I just said a whole bunch of things for y'all. Any questions for me about schedules, expectations, reviews, anything like that? I want to go to sleep. We were talking about sleep before I started recording. I'm a little tired myself too. Okay. I don't see any questions, so we are going to get started on our questions to work on the GoFormative. But the first thing I want to say is, because someone's going to ask me this, I'm going to answer it right now. When I'm asking you to prove if two functions are inverses, and I ask you to do it through composition, you need to find f of g of x and g of f of x. I don't just want it one way, I want it in both directions. That's because if they're inverses, we have to prove that f of x is the inverse of g of x and g of x is the inverse of f of x. So we do need to show both ways, not just one of them. So I will be looking for that in your work. But I'm going to stop sharing my screen. Today, like I said, we're going to be working about half the GoFormative. It's only about 7 questions. We are going to be going over problems 1, 2, 4, and 5. We're going to be going over problems 1, 2, 4, and 5. Problems 1 and 2 should hopefully be very quick. They're based off a graph that's been posted there for you. And 4 and 5 is just, here's two functions. Are they inverses? Are they not? Can you prove it to me? And that's the plan. So I'm going to let you work in breakout rooms for about 15 minutes. I'm going to call everyone back at 12:25. Please work on these problems. If you finish these problems before we come back, work on some others. If you don't finish these problems by then, that's okay. We'll still go over them together. And I do want to say this class has been really good about working on their GoFormatives. I say I probably have an average of about 75% of the class is doing all the GoFormatives. Which is pretty on par for like in building for like the amount of students who are doing their homework. So thank you for that. I do appreciate that. Just a reminder, you can go back at any time, even if you haven't done the 1.1 day one, like our very first GoFormative, you can still go back and do that. And I will mark that up for you if you'd like. But again, we're going to be working on problems 1, 2, 4, and 5 from the 4.2 day 2 GoFormative. We're putting you all out in breakout rooms until 12:25, and you should be getting the invite for those breakout rooms now. I'm going to pause this recording. Hello, we are back from our breakout rooms. We're now going to be going over problems 1, 2, 4, and 5 from the 4.2 day 2 GoFormative. A few things I do want to say though. Someone asked me about the notation of number 6, and I will be talking about kind of like why it's set up that way. I'm not going to work through the whole problem, but for problem number 7, a few people called me out on how monstrous number 7 looked. And yeah, it's not the most fun problem, but I think we need to work on our algebra skills a little bit. So just keep in mind, if you ever have any questions or if you want to work through problems together, stick around after I release all of you. So if you're like, I just want to see Miss Twain do number 7, stick around, let me know, and we can work through problem number 7 together. So just keep that in mind. But like I said, I'm going to share my screen with you so we can work on problems 1, 2, 4, and 5 from the 4.2 day 2 GoFormative. It hurts to look at number 7. I think I think you can do number 7. That's why I give you these problems. It may not be the most fun, but I think you can do it. Anyway, I'm gonna share my screen with you. Also, you may be able to hear my email. I don't know why it started giving me 2 alarms or 2 dings every time I get an email now instead of just 1. So I'm not as popular as you think I am. That's just my computer settings. Anyway, problems 1 and 2 should go fairly quickly. Give me one moment while I set this up. So problems 1 and 2 are on the graph. 1 and 2. Oh, question in the chat. Is there going to be anything like number 7 on the test? I mean, number 7, I feel like is a level 4 type problem. It's definitely a lot, but it's asking you to find inverses through composition, which is something I feel comfortable saying I will test you on. I feel like you should be able to deal with fractions. right? That's not, I think, too much of an ask. So if I was to put a problem like number 7 on the test, it would definitely be a level 4 type problem. And keep in mind, I don't know if any of you have had me in an academic class. I don't think you have, but I'm all about that partial credit. If you can at least get me started or show me something, I won't just mark you wrong immediately. But again, stick around. We can work through problem number 7 and truly see that I don't think it's going to be that bad. It's not going to be as bad as we think it's going to be. But before we get to number 7, let's work on problems 1 and 2. Keep in mind, this is F inverse and F inverse. So normally, when we have something like f of x is equal to some y value, right? That's normally how we have it set up. But when we're dealing with inverses, we always switch our x and y, whether that's when we're solving or when we're graphing and we're reflecting it over that line of y is equal to x, right? We're always going to switch our x and y's. So when we're looking at our f inverses, we'll have f inverse of y is equal to some x value. So in this case, f inverse of 0, this is like saying when my y value is 0, what's my x value? So in this case, when my y value is 0, my x value is -2. Someone in the chat, anyone in the chat, doesn't have to be from a specific breakout room. Can you tell me what is f inverse of 2? Or when 2 is my y value, what's my x value? Got someone giving me an answer. Can we get a confirm deny from anyone else? I sometimes like to have multiple people let me know. Correct, correct. Yes, it is in fact correct. I got a lot more people letting me know, thank you. Just in case someone says something that's like, well, maybe that's right, maybe it's not, but we're all confirming that it is in fact 0. So when our y value is 2, our x value is 0, perfect. So that's all you have to do for this problem. You don't have to do anything more than that. So hoping you can do part 3 on your own. Someone else is leaving another comment about problem 7, saying it is super complicated. I think problem 7 is complicated, especially because you have to do the composition in both directions. So that is a little bit of extra work. But again, feel free to stick around after we go over now problems 4 and 5, and we can work through that together if you'd like. But speaking of that, let's move on to problem number 4, and let's maybe start with a maybe not as complicated problem. Problem 4, where we have f of x is equal to 4x minus 8, and g of x is equal to x over 4 plus 2. And I want you to say, are they inverses? And we have to explain by using composition. So first, we're going to find f of g of x, where we plug our g of x inside the function. So we're going to have 4 times x over 4 plus 2 minus 8. So again, we're plugging all of our g of x inside of f of x. Now we have to use our algebra skills, see what we get left over. So I'm going to distribute this 4. We got multiplying by 4 and dividing by 4. That cancels out, just gives us x. 4 times 2 gives us plus 8. Minus 8, oh hey, that plus 8 minus 8 cancel out. We're just going to be left with x. But we can't stop there. We also have to go the other direction. So we'll have g of f of x, where we will plug g of x, whoops, there we go, g of x inside, f of x inside g of x. So this will be 4x minus 8 divided by 4 plus 2. So we've plugged in our f of x. When we go through and solve, if we divide each of these by 4, remember, don't just divide by 4 here and leave with the 8. The 4 also has to be divided here, giving us an x minus 2. So each of those pieces are divided by 4, plus 2. And the plus 2 and the minus 2 are going to cancel each other out. So what this means is when we put the functions inside of each other, they have the opposite operations and they're kind of pulling each other apart until we're left with our most simplest function, or you can think of it as a parent function, of just x. So if we're left with just x, we can write a conclusion statement. So make sure you write a sentence. Don't just tell me yes or no. But I might say, since f of g of x is equal to x, because that's what we wanted, and g of f of x is equal to x, then f of x and g of x, f of x and g of x, let me know in the chat. Yes, are these inverses? No, they are not inverses. What does this mean? We got one yes, we got a yeah. Okay, we got multiple people. Yes, one with an exclamation point. Yes, they are inverses. Are inverses of each other. Excellent. So this is one full problem. I will let you know if I give you a problem like this on the test. Excuse me, cough. I would write this as 3 separate problems. I would write this as like, find me f of g of x. I would write this as find g of f of x. And then I would write, you know, give me a conclusion. What does all of this mean? So like I said, we're in the process of writing the test, and just the test might look a little long because we've taken what is essentially like one problem and we've broken it up into parts to make sure that you're doing all of the parts and not missing anything. So keep that in mind. Any questions about problem number 4 or problems 1 and 2? I forgot to ask about that. Questions about problems 1, 2, or 4? Okay, so let's try this again. Let's do problem number 5. Get another email. It'll ding again in a moment. There it goes. All right, so f of x is equal to 3 minus 2x. We've got g of x is negative 1/2 x minus 3. Again, we want to prove these are inverses through composition. I don't know how to turn that off. I'm so sorry. So we'll have f of g of x. So 3 minus 2 is negative 1/2 x minus 3. So again, we're going through, putting g of x inside of our function. We want to see if the operations undo each other to get just x. So I'm going to start by distributing. I'm going to distribute not just 2, but a negative 2. That's important. Distribute the negative. We're going to have 3, let's see, negative 2 times negative 1/2 is going to just be a plus x. And then because it's a negative 2 times a negative 3, that's going to be plus 6. So overall, I'm left with x plus 9. So let's see what happens when we do, oops, came in, there we go. G of f of x, we have negative 1/2, 3 minus 2x minus 3. So we're plugging in, whoops, our f of x inside here. So I'm going to start by distributing this negative 1/2, multiplying that through. We'll get negative 3/2 plus x minus 3. And once we combine our like terms, we get x minus 9/2. Or if you did this as a decimal, which is perfectly fine, you might have minus 4.5 instead. So we see that we don't just have x. There's some extra things that didn't quite cancel out. So in my conclusion statement, I might say, since f of g of x doesn't equal x, and g of f of x doesn't equal x, then f of x and g of x are they functions? Yes or no? F of x and g of x? So we got no exclamation point, we got no, we can no, that is all correct. If there's anything extra, no matter whether it's plus 9, minus 4.5, times 2, whatever that is, if there's anything other than x, then they are not inverses of each other. So just keep that in mind as you're working through. They may not be inverses, and that's okay. It just means you're showing me how you know that and why you know that. We have the word weight in the chat question. Why would you have to do the second part if the first part is already not just x? Because we're not only proving that f of x is not the inverse of g of x, but that g of x is not the inverse of f of x. You have to show it in both directions. You do need to do it in both ways. So but this also means that if you get to here and you're like, okay, they're not inverses, and you do this, but you do get just an x, you know you have to go back and check your work, right? Like you should have either both x's or not both x's. So it's kind of a nice way to check your work as well. Any other questions about problem number 5? Okay. Before I let you go, we still have like 30 minutes left in class. I just want to talk about problem 6 and why it's written the way that it is, but I'll let you work on that one on your own. So problem number 6 is written thusly. So it's x minus 2 squared, parentheses, x is greater than or equal to 2, and that g of x is equal to the square root of x plus 2. So here's the thing. Squared, that's a parabola, it's quadratic. That looks something like this. My beautiful, beautiful rough sketch. Y'all are gonna find out I am not an artiste. But if we were to like very generically find its inverse and reflect it over the line of y is equal to x, the inverse would look something like this. But the only problem is that this inverse is not a function. So in order to make sure that its inverse would be a function, is we've got to restrict the domain. Wow, stop it. So if I take out this part of my original function, say x has to be greater than or equal to this, whatever number is right here, what that does is that takes out this part of its inverse, saying, hey, we only have this part of our inverse, which is now a function, and it's only the positive piece. That's why when we're graphing, for instance, like g of x, this doesn't have the plus or minus out in front when it normally would, because if we had the plus and the minus, that's what creates that sideways U. But if we take out one of the pieces, normally the minus, then it still stays a function. So I just want to say that's why we have this caveat here, or this stipulation. It doesn't change the math in any way. You still plug this into this, and then plug this into this, and that's how you check. Wouldn't a sideways U not be a function? Yes, that's correct. That's why we include this restriction. Because if we include the restriction that, hey, x has to be greater than or equal to 2, then in this example, x can't be 1 or 0 or -1 or whatever was over here. So we only have this piece of the function. So when we find its inverse is still a function as well. That's why we have this caveat. That makes sense? Okay. So I'm going to stop sharing my screen.
Wait, for number 6.
Yeah.
Sorry. For number 6, if you like plug in like the g of x and the f of x, doesn't that mean the square root gets canceled because of the x squared?
Mhm.
Thank you.
So like I said, I'm still going to let you solve the problem on your own and things might cancel correctly. Actually, I don't remember. I think these are inverses. I honestly don't remember. I'd have to retake a look. Let's take a look at that. I'm going to stop sharing my screen. We have about 25 minutes left in class, and you have 3 more problems to do on this Go-formative. So your homework for tonight is to finish this Go-formative and maybe go back and finish any other Go-formatives you haven't done, as well as at least taking a glance at the review. One of the reviews is just a PDF, like work on what you want to work on. One of them is a Go-formative. So maybe just take a glance at both of those, maybe do a few problems, but we'll talk about that a lot more tomorrow, along with what the test looks like and tool credit. So that's what tomorrow is going to be about. Stick around if you have any questions about previous Go-formatives, about any of the problems we just went over, or if you're like, I want to see Ms. Twain do number 7, feel free to stick around and we can go over that as well. Otherwise, if you'd like to go finish the Go-formative on your own, you very much may do so, and I will see you tomorrow. Bye, everyone.
Thank you.
Thank you.
Thank you, everyone. Bye. All right, I'm going to pause this recording.